elimination method? Is that what you're all going to try and do? Was everyone along the elimination method? Hopefully,
I noticed that when I started.
if you do 1 and 2, look, what would we try and do? Multiply by, so should we multiply this one by 4? So my number 1 becomes minus 4x plus 8y equals, number 2 is still 4x minus 8y equals negative 64. Okay guys, so you will notice then, it doesn't actually matter which one you choose. They're both the same, right? And they're both positive and negative. Look, there's no symbol, but I can put a positive symbol in front of that. So if the symbols are different, what do you do to eliminate? Add them. Yeah. But if I add them, exactly what Sam said, this becomes
You just have 0.
0.
Whole thing.
This becomes not the whole thing. This becomes 0. This becomes 0. 0 plus 0 plus 0. Yeah, is there a line there? No, it's fine, right? Absolutely true. 0 plus 0 is 0. What's the problem with that? Well, it doesn't tell me what x and y are. What do you think, Taylor? It doesn't need to be, but I like what you're thinking. Those two are not going to be horizontal or vertical lines, but what I'm thinking you're actually suggesting doesn't need to be horizontal or vertical. All right. What you might, well, we'll have a look at it in a second, but let's have a go. So Sam said we can't use elimination method. Now I've already told you we can't use substitution method either, but shall we have a go at that? Let's take number 1, and I'm going to rewrite it. So take my number 1, I'm going to add x to both sides to start with, so I get 2y is equal to 16 plus x, and I'm then going to subtract the 16 from both sides. Why have I done all that? Because I want it to equal x. Why did I choose that equal x rather than equal y? Part of the decision making we talked about. The reason is because I know it's 1x, everything else is more than 1x, more than 1y, I just want 1x, right? Then the substitution method says, well, I can replace x with this. So in number 2, all right, I can now say, so in my number 2, I can say 4 lots of 2y minus 16 minus 8y equals negative 64. Yeah? So I've substituted in. What do I do next? Yeah, let's multiply out. So I've got 8y minus 64 minus 8y equals 8y's minus 8y's. Cancels out. Minus 64 equals minus 64. Great, again, no problem with that, right? Nothing wrong. So, but it does lead me to a problem. I've done 2 methods, both my methods, and so it's like, well, what am I doing? I still can't find x's and y's. There must be a reason for this. Does anyone know what that reason might be? It's not because it goes to 0, actually. It's not just that. That's not a reason. I think Taylor was sort of just right. I think you probably can visualize what's happening. Let me show you. So here's the second one we're going to get to do. If I actually graph them, you'll see the problem. Here's the graph. I can't do it while I'm on this. Here's the graph of the first one. Okay, got it? So when I click the second one, what we're looking for is where the lines meet, yeah? So they share a point, yeah? So if I draw the second one, those two are basically the same line. So one of them is just the equivalence transformation of the other one. So what we actually say here, in this case, all right, it's not that we can't do it, it's that we actually have an infinite number of solutions because it's true for every value of x and y because they're basically the same line, right? Does that make sense? So this is where we start talking about the number of solutions. So normally you found one value of x and y that works. So what's coming next? You've got time? Yeah, you've got time. You've got 10 minutes. Have a go at this one. Let's have a look then. So these two, what would you try and do? Add or subtract? Add them. Why?
Because they're opposite symbols.
Okay, opposite symbols. But we're kind of coming up with the same problem again, aren't we? So this would be 0 plus 0 equals 4. Sorry, no, you confused me before. It's not, is it? It's 88. So with the previous one, I said to you, there's no lying happening. Like this one, 0 is equal to 0. I am perfectly up with that. That is true. Negative 64 is equal to negative 64. No problems with that. I might have a slight issue with saying 0 and 88 are the same thing. Because if someone said, I'll pay you $88 and then gave me nothing and said, oh, it's the same thing, we'd have a bit of trouble to sort out. All right? So that's not true. We have an issue. Very unhappy with that result. Why? I'm not going to bother with the substitution method. You could do that if you want, but we will end up, as you said, with the same result. The method should not affect the result. Right? Might be worth looking into doing it though. Does anyone have any idea why this is the case? Can you spot anything? No? Should we graph it again? Sam? You're on it, aren't you? You're on it today. Look at this. If we, those two, look, from before were basically the same line. They met at every single point. If I were to do this, these two, they are parallel. Now, if with your knowledge of straight lines and being parallel, what can we say? They have the same. Well, it's not the same equation, but in the equation they would have the same. Begins with G. Gradient. Well done. Good stuff. Have the same gradient. And so you'll notice that by changing that value at the end equals 24. It's not now the same line, it's a different line, but they're parallel. So in terms of what we talked about before, I said to you this one has an infinite number of solutions because they're basically the same line. How would we sum this one up? Well, the lines are an infinite number of points, but I'm after solutions. How many solutions are there where these... So basically, if you remember, this is why I went over and over and I kept repeating it. What we're trying to do is find the value of x and y that works in both equations. So the solution is the value of x and y that works in both. So this first one here has an infinite number of solutions because every value of x and y that works in one works in the other because it's the same line. What can we say about this one and how many solutions there are, Taylor? Excellent. There are no solutions. Because the lines, as you've already said, are parallel. They will never meet. And remember what I've said, we're not talking about lines that magically draw themselves to a point. When lines meet, it's because they share a point. They share an x and y value. If lines are parallel, they share no point. There is no point that will ever be on both lines because parallel lines never meet, like train tracks. So we have 3 options now. We have some where there might be one solution. We'll have some where there is an infinite number of solutions. And we'll have some where there is no solution. You actually need to be aware because, do you know what? As you get better at your maths, I'm not going to always give you questions that definitely have just one answer. You need to be aware that sometimes there'll be 1, maybe 2, maybe 3, maybe all the answers. You need to be able to get to that stage. When we get into quadratic and linear and cubic and the simultaneous or systems of equations, there'll be several points that are shared. Okay? All right. I think having gone through that, in tomorrow's lesson, I'm going to set you the task, all right, which basically deals with this. So you're just going to be a little bit on top of it, but basically summing up what we've talked about today. But it's going to be a criterion B assessment. I think with the amount that's in it, we'll probably have tomorrow's and Monday's lessons for you to work on it. All right. I'm going to be massively generous on this and say that you can work with the people that you normally work, but each one of you must produce your own individual response to this. So you can talk about it, you can discuss your ideas with each other and explain, but you must produce your own piece of writing. I don't want to see the same thing written in each person's, right? That's how I can then assess whether what you are saying. Yeah? Does that make sense? So I'll let you discuss, but I'm not going to let you all write exactly the same thing. Just do in your own words. So we'll start that tomorrow. It's about this stuff to do with the number of solutions. So this is recorded.